No more need for allergy meds. Check this out, you guys. This is a review on histamine and immune from Catherine G. I've been trying to find a way to live without a constant need for allergy medications. This worked like a dream. I'm loving it and would recommend it to anyone struggling with allergies. We get so many reviews like this on our histamine and immune supplement at Heart and Soil Supplements. It's desiccated organs, including liver, but also things like thymus and kidney with DAO, diamine oxidase, that can definitely help with allergies from a lot of different perspectives. We also just released Mood, Memory, and Brain, and I am super excited about getting more brain in my diet and helping you guys get more brain in your diets. If you heard the recent video that I did on the power of phosphatidylserine and sphingomyelin and sphingolipids and BDNF, all derived from bovine cortex, from cow brains. Desiccated cow brains, what we put in our Mood, Memory, and Brain supplement, along with liver and bone marrow. These compounds are powerful. Specifically, phosphatidylserine has been studied in age-related cognitive decline and found to be improving, found to be helpful for that, and also in young individuals in stress resilience, et cetera, management of the adrenocorticotropic hormone type pathway. So check out Mood, Memory, and Brain from Heart and Soil, and check out histamine and immune if you have allergies. Those are the two I will highlight today. I'm so proud of what we do there with grass-fed, grass-finished, regeneratively raised animals, organs, desiccated, freeze-dried, carefully packaged, and shipped to you in glass containers. I should also note that there has never, ever been a recorded case of bovine spongiform encephalopathy in New Zealand. This is not an issue there, so you can safely consume bovine brain and get the benefits without worrying about that kind of thing. So at Heart and Soil, we help you reclaim your birthright to radical health. That is what we are all about. My guest on this week's podcast, as I say in this podcast, is perhaps the closest thing. He is perhaps the closest thing that I've had on the podcast in Indiana Jones. Maybe I'll have somebody else who rivals him in the Indiana Jones status, but Dr. Bill Schindler has a PhD in archaeology. He co-starred in National Geographic's show, The Great Human Race, which was actually kind of an interesting concept that you can find on YouTube from 4 or 5 years ago. He and his co-star, Kat, went across the globe, and National Geographic pitted them against the elements at different points in human evolution. But Bill has sort of parlayed his archaeology knowledge into travels around the world looking at indigenous cultures, and recently wrote a book called Eat Like a Human. We had an amazing, really interesting conversation about how humans should eat, what an evolutionarily appropriate diet for humans actually consists of. I think you guys are really going to enjoy this one, and you're going to see a lot of similarities in the way that Bill and I think. And I think we talk about some of our differences as well, but really interesting conversation with Bill. And you can find him at eatlikeahuman.com. If you like this podcast, please leave me a review on Apple Podcasts. A 5-star review there goes a long way toward helping us spread this message. You guys are all part of my tribe. You are truth seekers. You are rememberers. And so I ask for your help in spreading this message of evolutionarily appropriate diets, radical health, challenging the norm, thinking outside the box, and helping many, many millions, hundreds of millions, perhaps billions of people benefit from what we know to be true, which is that eating meat, organs, and the least toxic plant foods results in radical health for so many of us. Why should so many continue to suffer if this knowledge is out there? That's what I'm doing with my podcast and what we do with Heart and Soil. Please leave me a review at Apple Podcasts to help us spread the message. As a thank you, I give away one signed copy of my book every month to somebody who leaves me a review there. All right. Without further ado, on to the podcast with my man, Bill Schindler. Enjoy this one, guys. Let me know what you think. Bill Schindler, thanks for coming on the podcast. Been a long time coming, my friend.
It sure has. It's a pleasure to be here.
You know, I think you are probably the closest thing I will ever have on the podcast to Indiana Jones. So I'm excited about this.
Yeah, me too. I know we've been trying to connect for some time, so I'm glad it's finally happening.
Yeah, it's good. You've got this book coming out, Eat Like a Human. We're going to be talking about that. But I want to start with, I didn't know this about you until I started digging into your past in preparation for this podcast. Mm-hmm. I don't know how this escaped my radar, but 5 years ago, you were in a show on National Geographic called The Great Human Race.
Yes.
tell me about that. Like, it started in Tanzania, but where did you go? Just tell the listeners about this show, because it's pretty crazy what you did.
Yeah, actually, I think we started in the same place you were in Tanzania, so we have a lot in common there. About 6 years ago, National Geographic contacted me. They were thinking, at that time, as you know, they were everybody was scrambling. The survival TV shows, reality TV shows were kind of hitting on it. They were starting to die a little bit, and everybody was looking for stretching these reality TV shows and doing something silly to get somebody's attention. They were putting naked people on there, and they were handcuffing people together and sticking them in the middle of the woods and trying to survive. All these silly things. But National Geographic, I really give them credit, wanted to capitalize on sort of the survival TV genre and sort of the wave that was there, but do something smart with it, something meaningful. So what they wanted to do was tell a story of our shared ancestral past using the survival TV, as a platform. So they contacted me to be one of a team of 2 people, me and Kat Bigney ended up being my co-star. And the idea was, starting at 2.5 million years ago, they were going to put us in a different location where something at that particular time period was invented or was done by our ancestors that made a difference. It was worth telling a story about. And my job, I'm a prehistoric and experimental archaeologist and primitive technologist. So my job was to replicate the technologies from that time period, and we use those technologies to clothe ourselves, to feed ourselves, to protect ourselves, all those things. And we're able to really tell people what it was like to experience. Again, it was only about 10 days at a time, but what it was like for a modern person sort of to experience these different major time periods of our evolutionary past. We started at Tanzania 2.5 million years ago, went up through Africa, crossed the Middle East, crossed Asia, and ended in Oregon at 4,000 years ago.
Yeah. Okay. So let's walk people through a few of those stages. So 2.5 million years ago, you were using these Acheulean tools, right? Or were different types of tools at that point? But 2.5 years ago, what kind of tools were invented?
Well, it's funny because at the time, 2.5 million years ago was the beginning of our of stone tool technology, or at least as we knew it then, and we now know it dates back to almost 3.5 million years. So things have changed. But the idea was that the first technology our ancestors, we believed at the time, ever created was Oldowan technology at 2.5 million years. It was pre-fire. At that time, those tools allowed our ancestors to go from purely scavengers, eating nothing but a limited amount of seasonal wild fruits and plants and a whole lot of insects, to scavenging, and that was the introduction of meat into our diet. And then the next major transition happened at about 2 million years ago, which I think is the most important transition in our evolutionary past with regards to diet, where we invented hunting technology. It allowed our ancestors to become the predators, and we were no longer scavenging. We had access to the most nutrient-dense bioavailable parts of the animal, the blood, the fat, and the organs, and the flesh. And we also invented fire at that time. So the second episode was hunting technology, basic Acheulean technology, stone tool technology, and fire technology.
And the Acheulean tools are like the bifacial tools. They're almost like a stone knife or a spearhead, right?
Actually, I'm glad I'm sitting here, because I have. Give me a moment. I have an example right here for you.
Perfect. For those who are watching, you're going to get this. Maybe we'll put a highlight of this onto Instagram or something. But if you want to see this Acheulean tool that Bill is going to grab, you can check out this video on YouTube.
Right. So the first stone tool. Well, let me back up, Paul, because I do want to say, even though the show started at 2.5 million years ago, that was our kind of anchor. We now know that stone tool technology was first invented, or at least we believe now, at 3.3 million years ago, so 3.5 million years ago. And though it was a very basic stone tool where you had 2 rocks of the right material, you bang one against another, and you produce, in less than a second, a razor-sharp edge. And it sounds so simple, and it sounds like kids playing, but think about the power of, before any of those stone tools were ever invented, our ancestors, who stood up full grown, about 3.5 feet tall, were not as strong as us. Their nails were useless, their teeth were almost useless. Their interacting with the environment was limited to their biological adaptations. But as soon as they struck 2 rocks together and produced a razor sharp edge, that edge, even though it was produced in less than a second, was stronger and sharper than anything on their body they could use to cut or grab or slice. So it was simple but transformative. At 2 million years ago, they started creating a tool like this. And for those who can't see but are listening, a bifacial technology means, bifacial meaning two faces. So our ancestors at this time were controlling removing flakes from two sides of the rock in a very, very controlled way. And we're able to produce these, we call them hand axes, but as you can tell, if you've ever dug into the ground, chopped down a tree, this point on the end doesn't work very well. This was probably used, we believe, for butchering large animals and for digging into the ground to extract things like underground storage organs, those sorts of things. Beautiful. And what's also an important takeaway here to understand is, if anybody's ever played, I grew up in the 70s and 80s, we had Rubik's Cubes, and when you really just start learning how to use a Rubik's Cube and you can get the one face, right, the same color, and then you go to try to do it on the other side, and when you're trying to get the other side, you're messing up the first side. It's the same sort of thing with this, it's very advanced technology to be able to control two faces of this rock at the same time, because everything you do something to one side, you change some angles and some morphologies on the other side. It requires advanced planning and understanding of the fracture mechanics of these rocks.
Now, is that an actual Acheulean tool, or is that a recreation?
This is a recreation that I did.
Oh, you did that yourself?
I did this myself, yeah.
How long did it take you to do that?
To do this one uninterrupted, with the right kind of rock, and if I don't make any mistakes, I could do something like this in about a half an hour.
Okay, with practice.
But it's also important to understand too that, and I know it's so hard because you talk about something so powerful as stone tool technology and go in different directions, but to crack one rock against another and produce a razor sharp edge, anyone watching somebody else do it could pick it up and literally pick up a rock and do it by mimicking. But a technology like this requires practice, and it also requires, I'm convinced, some sort of purposeful transfer of knowledge, somebody teaching somebody else, how to do it. Suggestive
of higher cortical development in a hominid brain, right?
Absolutely. And these several things come together all at the same time. When we start hunting and access the most nutrient-dense part of animals at will, and have the ability to cook our food, which in some cases really helps not only detoxify foods, but helps make some foods more nutrient-dense and more bioavailable, and the production of these stone tools, which requires higher cognitive thinking as well, it's the same time that our bodies and our brains grow exponentially to almost modern proportions. And there's no doubt that all of those things happen at the same time for a reason.
Right about 2 million years ago is kind of that magical point in our history.
Yeah, absolutely. Absolutely.
And this is such an important point. It really can't be overemphasized. I just want to walk you through it one more time. So what Bill is describing is something that I've talked about in the past as well, which is this transition, and correct me if I make any missteps here, Bill, this transition from Australopithecines, Australopithecus afarensis, these sort of Lucy type fossilized remains, these pre-hominid ancestors, somewhere between a primate and a human. We don't really know what to call them, Australopithecines, transitions to Homo habilis about 2 million years ago. And as Bill is saying, when we were Australopithecines, we were probably eating things like bugs and fruit and maybe a few seeds. So, and then suddenly 2 million years ago, between 2.5 and 2 million years ago, we began to scavenge 2.5 million years ago with these Oldowan tools, the striking of two rocks together to make a single edge. And then 2 million years ago, these Acheulean tools, these bifacial tools, allow us to actually cut meat away and hunt. And then suddenly 2 million years ago, our hominid ancestors become Homo habilis with access to, this cannot be emphasized enough, the most nutritious foods on the planet. Would you agree with all that?
Absolutely. There's a couple of things that have happened recently that I think, yes, a couple of dates I think are good updates from that. That's a really good outline. One is, somewhere between 5 and 7 million years ago, our ancestors, we stood upright for the first time. And we also, there's some suggestion that in addition to limited amounts of wild fruits and wild plants and a bunch of insects, they may have been targeting some underground storage organs, some carbohydrate-rich roots, corms, and tubers. We don't know that for sure, but a lot of people are suggesting that. The new date for scavenging has been pushed back to about 3.5 million years ago with the production of what we now know as the first stone tool. We call it the Lemekwe tool. It was just west of Lake Turkana. This was found. We've not only found the tool, but we found the butchered remains of scavenged animals. So we find the tool, and we know for sure they're hacking on bones. Again, they're not hunting, right? They're scavenging the kills that were made by predators. And I think for everybody listening, and I'm sure they might already know this, but we understand predatory behavior on the African savanna by watching modern correlates of the ancestors. So the animals that were running around 3.5 million years ago on the savanna were not lions, and they were the ancestors to the modern day lions, just like, you know, they're our ancestors as well. So their ancestors, who were some nasty, crazy predators, were out there taking down animals, jumping on them, using their huge canines to rip these carcasses apart. And we know by looking at the behavior of modern predators that their behavior was the same in the past. They would take these animals, take them down, rip them apart, dive into the inside, and access the most bioavailable nutrient-dense parts, the blood, the fat, and the organs, gorge themselves like most Americans do on Thanksgiving, and do exactly the same thing. They go to the couch and sleep it off. And when they leave these carcasses on the savanna, these animals that are biologically equipped to go in and scavenge, things like the ancestors to modern day hyenas and buzzards, will go in, rip off flesh, and do their thing. The problem was our ancestors were not biologically equipped to join that party. They could watch it as they're munching on some termites, but they couldn't go do it themselves. When they created this stone tool, it provided them access. They were no longer limited to their own physical limitations. They could go out there and hack off huge hunks of meat, bring them back to the elderly, the young, the sick, eat it themselves in safety somewhere else. But what I think is a real big takeaway from this is that when they start introducing meat into their diet, we don't see huge biological changes. We see a little bit. There's a little bit of body size growth, a little bit of brain size growth, but we don't see these massive changes. The massive changes happen when our ancestors start hunting and also control fire. And the difference between scavenging and hunting is the hunters have first access to the most nutrient-dense parts of the animal. And that happens in 2 million years. Yeah.
And let's emphasize that's the blood, the organs, and the fat, right? So that's
period.
So, yeah. So in my book, The Carnivore Code, I suggested, my hypothesis, my position was hunting made us human. And I think that this is exactly what we're talking about here. But you're sort of highlighting a point that I don't think I realized as well, that the hunting gave us access to blood, organs, and fat. We probably had access to meat before that as scavengers, but it was blood, organs, and fat that really made us human, and that really allowed us to become the form of Homo erectus and then Homo sapiens that we understand to be today, that we are understood to be today. And so this is such an interesting conversation because I think this is sort of a question that I'll throw out there for a future podcast. You're welcome to comment on it if you'd like, but I'm not sure how plant-based advocates and vegans can know a shred of anthropology or archaeology and still not understand that the very foods that made us human, this unique access to blood, organs, and fat, in addition to meat, these were clearly the catalyst, in addition to fire. These were indispensable parts of our human evolution, and now we're being told, based on badly done science, observational epidemiology, these foods are bad for us. It's like, it doesn't make any evolutionary sense. Do you see the vegans doing this and think this is incongruous in the same way that I do?
Oh, absolutely. And I think, it's so hard. I was with Brian Sanders and Mary Ruddick. We did a Instagram Live the other day when I just got back from Ireland last night. So I was up in Ireland. They were down in Mexico doing some work, and we were talking about something very similar. And one of the things that I said was that the actual act of doing archaeology and excavating the ground and measuring and understanding soils, all of that is science. When you pull an artifact out of the ground, everything that happens from that point forward is interpretation, right? It's. Hold on 1 second. You've cut out on me. Are you still there?
Yep.
Okay, so you can hear me all right? I'll just keep going?
Yeah. Yep.
Okay, good. So everything that when you pull an artifact out of the ground, everything from identifying that artifact to trying to understand how it was used, how it functioned, how it operated in a cultural system, how efficient it was, all of those sorts of things are are open to interpretation. And even though we try very hard to approach the archaeological record in an unbiased way, it's impossible. We're human. It's impossible to do. So the way that we interpret archaeological sites is very much also a product of things that are happening in the world, in politics, and in understanding, human environmental relationships, all these sorts of things. So it's a lot of this is open to some sort of an interpretation and the importance of it, but there's no doubt. We know for sure that we were scavenging. Meat has been in our diet for 3.5 million years. The entire animal has been in our diet for 2 million years. And we see the biggest growth in body and brain size when we start introducing animals into our diets. But sometimes you start under some of the couple things that I think are very important. Ammunition isn't the right word. Responses to vegan interpretations of the importance of vegetables in the past. Number one, sometimes I hear things like, well, we've been eating vegetables for 5 million years, actually before that, millions and millions and millions of years. Yeah, but they were small. Their brains were small, and they had a high level of what we call sexual dimorphism, right? The males were a lot larger than the females, and we think that's the case because the increased nutritional need of females when they're doing, from an evolutionary perspective, the most important thing that female members of a species can be doing is carrying a baby to full term, giving birth to a healthy baby, and nursing that baby until they can take care of it. I mean, that has to happen or else the species dies out. And there's massive increases in nutritional needs during those periods of a woman's life. So if the thinking is, if they start out with lower nutritional requirements in an environment where they maybe can't get all the food that when those nutritional requirements skyrocket, they can handle that. But what we see when you start introducing animals into the diet and these incredibly nutrient-dense, bioavailable foods that our bodies don't have to work that hard to get access to the nutrients in, that we start seeing a reduction in sexual dimorphism to the point where human females, yes, on average, are smaller than human males, but nothing like they were in the past. So that's number one. Number two, yeah, they were eating plants, but as you know, and I've heard you speak about it, and I'm not completely the same. All plants contain toxins, right? And all plants do, even our domesticated ones from the grocery store, the ones that are out in the wild, not only are the toxins more prevalent, but often they can do some nasty damage. So it's not like they're looking, the world is their oyster and they can go out like they're in the produce section of the grocery store. They are limited. If they don't have a technology to detoxify plants, they are very limited into the plants that they can eat. So it's by default hyper-seasonal, by default hyper-local, and their selection is incredibly limited because there's not that many plants that are safe enough to consume throughout. And then the other point is that the insects were the most important part of that diet. And there's been a lot of studies done with chimpanzees looking at the importance of insects. And again, one of the things we see is when chimpanzees are lactating, which is the highest nutritional need in a female's life when she's lactating, even more so than pregnancy, they go directly to insects, and their insect consumption skyrockets. So our vegan, or somewhat other than insect, non-meat-eating ancestors, the most important part of their diet were bugs. So when they start introducing animals, then we start seeing, huge increases in everything. The other thing I think is important to remember, too, I was doing a TV piece for an Irish food show several years ago, and the host said, because you said the word catalyst, it made me think of it. He said, was it the introduction of animals that made our brains grow larger, or eating more of these foods and having access? And I said, no, I think we're thinking about it potentially in a slightly skewed way. It wasn't eating animals that started our brains growing larger. We're not really sure what that mechanism was. And some people actually suggest hallucinogenic drugs. But regardless, there's a lot of things that may have been pushing our brains to expand. But it was finally our ability to support that brain growth with the right nutrition that allowed it to happen and supported that brain growth.
It's kind of a question of whether those foods were a catalyst or a releaser. Maybe there was an environmental pressure. Maybe there were gene changes. I did a previous podcast with Bill von Hippel. He talked about a certain gene that may have been involved in this brain expansion. But regardless, I think that the case is very strong that the inclusion of organs and blood and fat, the ability to hunt and get these most nutrient dense parts of an animal, was a critical factor, an indispensable factor in making us who we are as humans. And, the corollary point there that I'll make very clear to the listener, that hopefully most people listening have heard me say before, is that it just seems completely counterintuitive and evolutionarily inconsistent that those very foods that were at the center of our life, the center of our diet for literally millions, there's no hyperbole in that statement, millions of years, would somehow be bad for us. And it's interesting because in your book, I learned about the fire. When I was writing my book, the best data that I could find suggested that fire was 500,000 or 1 million years old. But apparently, I think we've got some new evidence now that fire is older than that. You say 1.4, 1.6, or even 1.8 million years. So I found that quite interesting that that according to the archaeological record, as you suggest, that fire has probably been with us for the majority of our time that we've been hunters.
Yeah, 100%. And so you can imagine how difficult it would be to find evidence. If you went camping right now, had a small campfire, let it burn it down to ashes, and then walked away from it and didn't do anything there for 2 million years and came back and tried to see that campfire, how difficult it would be, or near impossible, if not completely impossible, to find it in the archaeological record. So it's difficult to find these things. We have found direct evidence of fire that date back very far into the past. However, there's several people, Francis Burton, who's a fantastic anthropologist that wrote a great book, Dr. Richard Wrangham from Harvard. Many people believe that the control of fire, and I mean control of fire, I mean the ability to start it, put it out, control the temperature, control the light, control the heat, the ability to do all of those things with fire was somewhere around 2 million years ago. But the other thing I think is really interesting to think about is, and this is Francis Burton's suggestion or hypothesis, is that in order to get to the point where we are controlling fire at 2 million years, we would have had to start a relationship with fire millions of years earlier. I mean, think about it. We're like one of the only animal species on the planet that doesn't run and flee from fire. We actually come to it and build ceremonies and all sorts of things. It's an essential part of our life. So we had to start understanding that fire could provide benefits. We had to start understanding that we could fuel that fire, continue that fire, do all sorts of things with it. So it probably was in our lives for several million years to get to the point where 2 million years ago, we truly believe that, many of us believe that it was an essential part of our lives. We could control it. And, if none of the other evidence is enough for you, the one thing that I always go back to is it's also at right that same time, just around 2 million years ago, that we have, for the first time ever, our hominid ancestors leaving Africa and going up into Europe and the Middle East and eventually into parts of Asia. And so they're moving north out of Africa at around 2 million years ago. What's fascinating is that's the beginning of the last ice age. So we have our ancestors moving north out of Africa, going into northern latitudes at the beginning of the last ice age. The only way that is possible is if you're not only using fire to help prepare raw materials from different environments for food and diet, but also you're controlling your microclimate and you're keeping yourself warm enough that you're not going to die. There's no evidence for clothes until almost 200,000 years ago. So we have naked ancestors going into the ice age, and doing very, very well. They have to be able to control their microclimate.
And that's an interesting thing to just touch on briefly, the fact that our ancestors, that species, whether it's Homo habilis or Homo erectus, left Africa, and some stayed because Homo sapiens began in Africa 350 to 500,000 years ago. And then we see Neanderthals that left, before then, and then Denisovans. And so there's evidence for migration and egress from Africa before the appearance of Homo sapiens in Africa, correct?
Well beforehand, absolutely, yes. And I love to try. I'm a professor and teacher at heart, so I love to try to share with people I'm speaking to the scenes that are in my head, how I picture what some of these things look like. And I think, because it helps frame how we look at the rest of the world and all the kinds of questions that we're discussing today. One of the things that's also incredibly unique about now, that was never the case in the past for millions of years, is that right now we are the only upright walking, intelligent, tool-making, culture-having beings on the planet. But that's only a product of the last several, tens of thousands of years, past probably 30,000 years. From millions of years ago up until, from my lens, relatively recently, 25,000 years ago or so, we had multiple species of intelligent, tool-making, culture-having, probably speaking individuals coming in contact with one another. We had Neanderthals and Homo sapiens and Denisovans and all sorts of different. It's almost like that movie Quest for Fire, where you see the different species coming together. That's what life was like on this planet, and the fact that we're the only ones left is a really unique, really novel new thing.
And I don't think people, it's very humbling to imagine that Homo sapiens is the sole surviving species of these hominids, that many of them have gone extinct. Neanderthals, Denisovans. I've often spoken about this species Paranthropus robustus, which appears to have been, based on my understanding, a branch point from Australopithecines into Homo habilis and Paranthropus. Mm-hmm. And based on the stable isotope studies that I've seen, Paranthropus went more toward plant eating and Homo habilis went more toward animal eating, and Paranthropus went extinct as well. Are you familiar with that lineage?
Yeah, I know. I don't know enough to speak intelligently about what caused their extinction, but yes, they're definitely plant-based.
Plant-based. Cool. So you say something in your book that really kind of got me cheering, Bill, and we can dive into this. You say, plants should scare the hell out of you.
That is the opening line of that chapter, yes.
Yes. Plants should scare the hell out of you. I just, it's funny. I tweeted yesterday, call me the anti-broccoli crusader. And another tweet that I had that I thought was pithy and clever was, meat and organs are a great way to detox from eating vegetables. But talk to me about your perspective on how our ancestors might have approached plant foods. We've talked about animal foods. I want to circle back to that at the end of the podcast. Sure. And talk about your experiences in Mongolia with the herders there eating a yak. But talk to me about how our ancestors might have approached plant foods from your perspective.
From my perspective, super cautiously and with a whole lot of technology. Well, one thing I think we very much need to remember that is the baseline for all of my work and the way that I view the world and the relationship between humans and food is that the humans are incredibly biologically inferior to other animals on this planet, and we have an incredibly inefficient digestive tract. And a lot of people ask me, and I know I'm a little bit jumping around, but bear with me to kind of frame this properly. A lot of people ask me, what was the first domesticated species on this planet? And I say, well, how do you define domestication? Now, domestication to me means you take a species, take it out of its natural environment, put it in a cultural environment, in other words, an environment that humans have created. That environment tends to certain kinds of things, maybe gives it food or gives it light or gives it whatever, protection. And over time, that species in that culturally created environment changes genetically. And in some cases, changes genetically to the point that they can no longer survive on their own outside of that cultural environment. So if that's your description or definition of domestication, some people would suggest, well, if it's a plant, the earliest domestication of plants would have occurred around 15,000 years ago or so at the earliest. If it's an animal, most animal domestications were happening between 8,000 and 10,000 years ago, but the dog was domesticated probably much earlier, maybe around 35,000 years ago or so. But to me, using that definition, the first domesticated species on Earth were humans. We domesticated ourselves 3.5 million years ago when we started creating these first stone tools and because of the creation of these stone tools, we could access resources. We put ourselves in a culturally human-created environment, right, with these technologies, stone tools, fire, and a whole bunch of other things. We genetically changed because of through evolutionary processes as a result of this new environment we were in and our ability to access foods we never could before. And with the introduction of things like animal-based foods, our bodies and our brains grew to the point that we can no longer, we've domesticated ourselves. We can no longer survive outside of a culture-created environment. If we got rid of all our technology, and I say this all the time, I don't care if you're Bear Grylls, I don't care if you know the behavior patterns of all sorts of animals around the world, and you know all the poisonous and not poisonous plants and all that. If we stuck you in the middle of the woods naked, well, in most parts of the world, you die of exposure, but you couldn't feed yourself. It's impossible to do. So I say that because in my mind, the ancestral diet is one that is created through technology. Stone tools, and then hunting, and then fire and fermentation and all sorts of other sorts of things. And we've built our bodies on diets that were reliant upon these technologies to introduce foods we have no business eating. We biologically have no business eating, but we now require because our bodies are built on the backs of these. I say it all the time, we're omnivores not by design, we're omnivores through technology. So to go back to your original question, how do we deal with plants? The only way we've been able to deal with plants as long as we have is because, and we see this through time, and it's a focus of a lot of my research, we've figured out ways of taking plants and doing our best to make them as bioavailable as possible, make them as nutrient dense as possible, and make them as safe as possible. The thing with animals is that once you've taken an animal down and cut it open, that's all really the technology needs to do. I mean, there's some evidence that cooking meat a little bit helps make it a little more bioavailable. It's sure that especially with red meat, if we chop it up or grind it or slice it real thin, it's a little bit easier for our bodies to access the nutrients in meat and not have to work so hard. But the blood, the fat, and the organs, heck, in most cases, they're easier for our bodies to access the nutrients without the cooking than with the cooking. So the technology for animals, to me, is really about harvesting that animal and getting it cut open. And then for the rest of it, our bodies can do the work. But for plants, harvesting that plant is where the real work begins, because those plants, contrary to many people's thinking, plants are not put on this earth to feed us. Like, plants are put on this earth to do what they need to do. They need to survive and protect themselves, and they do it through chemical warfare. So they do it because they can't move. So they have all these toxins. So if you look at the technologies that our ancestors developed through time, and we continue to have to rely upon, we need to make plants safe, nutrient dense, and bioavailable as possible through technology. And that's how we've approached plants in the past.
Now, if you're thinking about plants, do you look at a plant and see that some parts of a plant are less toxic than others? For instance, in your book, you mentioned fruit and flowers, and I think about, roots, stems, leaves, and seeds being separate from those. But do you think about it this way? Do you think plant foods have a spectrum of toxicity? Are there some parts that are more or less toxic of plants?
100%. And I think this is where we can take a step back. It's so hard for some people, it's so hard to understand how our ancestors could just eat like other animals without having to overthink it, without having chemists and lab tests and all this. I mean, but it makes complete sense when you're connected to your food and where it comes from. And I've been a forager for now 38 years. I started when I was 10 years old, and that relationship with watching plants grow and harvesting and detoxifying has really helped me, I think, create this lens through which I look at plants. But it's as easy as this. Separate any sort of discussion about humans eating plants for a minute and whether you're supposed to or not. Just put that aside. Let's just think about the plants. Plants are trying to do the same thing as any other species on this planet. The things that all members of all species have to do: reproduce viable offspring, that then reproduce viable offspring, that then reproduce viable offspring. And if you do that, you survive, and if you don't, you become extinct. So plants can't move, so they do this through creating chemical and physical defense mechanisms. So the physical defense mechanisms are things like thorns or bark on trees or really hard nutshells, right? Those kind of things that protect the plant. But in all cases, plants have developed toxins to protect them from predation, from insects and fungi and animals that are trying to eat them and those sorts of things. For most of the plant, right? Because at a certain point, most plants then require their seeds or their progeny to get deposited somewhere and transported, and then at that place be able to create new life. So things like stems are there to hold the plant up. Roots are there in many cases as a storage mechanism for energy. Leaves are there to help through photosynthesis. None of that require, they don't want those parts to go away. But a flower requires, in many cases, pollination, and they want to attract something to it. So often they're brightly colored. Often they smell very good. Often they're very sweet tasting, or they're very sweet to draw things in. But more importantly, parts like fruits are there. They work because when they're ripe, they smell great, they taste great, they want animals to eat them, and then deposit their seeds somewhere else. But then when you think about things like seeds, nuts, and legumes, they're there to survive the digestive tract of animals. They're not there to provide nutrition. They're there, and that's why they're full of anti-nutrients and lectins and all of those sorts of things. So, the quick thinking about plants, there's different parts that have different toxicity levels for different reasons, and you can understand what that is by understanding the role of those different parts of a plant. And then if you understand all that, if you are going to eat plants, you need to understand how to make those plants as safe as possible. And then understand, as everyone listening already knows, even though there might be nutrition in plants, rarely are they there in a very accessible form to our bodies. We need to do something to allow our bodies access. And I'll say this, there are ways to do it. It's hard work, and you have to stay on top of it. But I don't write, for example, sourdough bread. My family even owns a sourdough bread bakery. I would never tell somebody who doesn't eat bread to go start eating bread, even if it's sourdough. But I will tell somebody, if you're going to eat bread, and if you're going to continue to feed your children bread, and it's going to be a part of your life, then there are healthier ways to do it, and it does make a big difference. And sourdough bread is by far the safest for the human body to consume.
Thank you for that. It's great to hear. I mean, I think that we think very similarly about this, and so that's great to hear your perspective also. Talk a little bit about fruit, because I think there was an anecdote in your book about how fruit actually sometimes contains toxins until it's ripe. Plants are so smart. They're so freaking smart. Like, until the seed that is in that fruit is ready to germinate or ready to be distributed, they're not going to make the fruit brightly colored. They're not going to make the fruit sweet. They're not going to make the fruit fragrant. I forget exactly what it was. Do you remember the anecdote I'm talking about in your book?
Oh, absolutely. So there's numerous fruits that are like this, but the example that I gave was a wild persimmon. So anybody, especially in East North America, so there's persimmons around the world. Most of them are the Japanese version, and it's the case, and that's a domesticated version. It's the case with this too. But the American persimmon, the wild persimmon, that if you try to eat that fruit before it's ripe, it's a strong astringent. It sucks all the water out of your mouth, and it's an incredibly unpleasant experience. But if you wait till it's completely ripe, which coincides with the time that those seeds are ready to germinate and support new life. I mean, this just makes such complete evolutionary sense. It is truly my favorite fruit on the planet. It goes from being something that I wouldn't give somebody I hate to something I go out of my way to try to access because it's that incredibly delicious. And it's an evolutionary response. Now, at the same time, there's another wild fruit in our area called the pawpaw, which, by the way, was George Washington's favorite dessert, was a chilled pawpaw. Anyhow, so it grows wild here, and the flesh, when it's ripe, same thing, is incredibly delicious. But the seeds are a powerful neurotoxin, and if you eat the fruit and you nick the seed and you get some of that seed, at best you'll be vomiting and diarrhea for 2 or 3 hours. At worst, it can actually cause death, and people die every year from this. But it's that same, it's there to survive your digestive tract, but it's the natural evolutionary mechanisms to ensure that plant, that seed isn't there for you to eat. That seed is there to produce another pawpaw tree.
Don't eat pawpaw seeds, guys. Don't even put the pawpaw seeds in your mouth. Holy shit. That's crazy.
No, don't do it.
It reminds me of when I go back to Austin and I try and eat a papaya, because here in Costa Rica, we have the best papayas. I cut it open. They're full of these like plump seeds. And no, I don't eat the seeds, guys. I know in like hippy dippy circles, they say the seeds are anti-parasitic, which may be the case because the seeds have a bunch of toxins in them, but I don't have any parasites. I don't need to eat papaya seeds. They're not good to eat if I don't have parasites. And, the seeds are plump and the flesh is just delicious and orange and juicy. And I go back to Austin and I made the mistake of trying to buy a papaya in the grocery store, and it was from Mexico. And I thought, okay, maybe. And I cut it open and it's just bitter and it's hard. And I'm thinking, this is not even good. Like, I just don't have any desire to eat that as a human, because that papaya was probably picked before it was ripe. It doesn't even want to be eaten. This is actually a big problem for me, Bill, living in Costa Rica, living at the equator, is I really like tropical fruit here. I love the bananas here and I love the papayas here. And I can't even eat bananas. I hope I don't do this, but I'm going to ruin people on bananas. All of you guys in North America eating bananas, your bananas stink. And my bananas in Costa Rica kick the butt of your bananas. Like, if you've never had a banana that grew on a tree in Costa Rica, locally here where I am in Santa Teresa, I have bananas in my freaking yard that I can eat. That banana like ruins you on every banana that you're ever going to eat anywhere else, because bananas are not native to North America and you can't get it ripe enough. It's not supposed to be ripe. It's usually ripened with ethylene or something. It doesn't taste the same. But that persimmon example is fascinating. And the pawpaw example is particularly pointed because it really highlights the difference between a fruit and the seed that is in the fruit. And I love that you pointed this out earlier. When we say the word seed, we mean grain, nut, legume, or seed. So why don't we let's talk a little bit about seeds and the way that we encounter seeds in our diets today as humans. And you hinted at this a little bit with sourdough bread, but the way that these seeds, the toxins these seeds have, and how we might go about detoxifying them if we insist on eating seeds.
Sure. So again, remember, that part of the plant is the reproductive part of the plant. And this is an example I give quite a bit in my sourdough classes. I bring out an egg, right, and I bring out a wheat berry, and I say, look, if we divided each one of these into the three major parts, there's a lot of similarities, right? First off, they're there to do the same thing, support new life. And an egg, it has the protective mechanism is the shell, then it has the whites, and then it has the most nutrient-rich part of it is obviously the yolk. And on a wheat berry or a grain, it's a very similar thing. The bran is on the outside, which is there mostly just as a physical protective mechanism. Then you have the endosperm, which is mostly just starch. And then you have the germ, the heart of it, which is the part, if you have whole wheat flour, that's the main part of it. That's the nutritional powerhouse as much as there can be. So there's some similarities there. But then there's a lot of differences. If I set that egg, an egg can remain viable to support new life for a couple weeks. A grain you can put on the table or on the road or in a parking lot or somewhere dry on a rock, and it can remain viable for thousands of years. And we've, on an archaeological site, have found maize, corn that's 10,000 years old that we've been able to germinate and grow into a new plant. Why is that? What's the difference? Well, that egg is relying solely on the shell of that egg as a protective mechanism, and it doesn't last very long, and then things are going to go bad. But there are so many chemicals that things like the anti-nutrients and the phytate, all of those parts of those chemicals on that grain, which in very many ways are similar, in many ways are similar to legumes and grains and nuts and seeds, all of it, that keep it dormant until it's in the right environment, that it lets down its defenses and then sprouts and then begins and creates new life. And the only way to even begin to make those seeds, nuts, legumes, whatever, safe for human consumption is to trick it into thinking it's in the right environment, that it lets down those defenses. And the first time I realized this, I was doing that same show in Ireland. I don't know. I think I told the story in the book. I forget. But it was actually a vegan episode for a series called What Are You Eating in Ireland? And I get a call from the producer and they're like, listen, it was the year I was living in Ireland. And they said, we're doing a show. We'd like to have you on it as a guest. I'm like, oh, that sounds great. What's the show about? And they said, veganism. And I said, I don't think I'm the right person for this. Why would you ask me? He's like, no. The host is going to go on. He's going to get all this blood work done. Then he's going to go on a vegan diet for like 3 months and then go and get blood work done at the end to see the changes. And during the 3 months, he's going to interview a lot of the members of the vegan community in Ireland, which is actually quite strong in Ireland. And then what we want to do to kind of wrap it all up is we'd like you to come out with us. Maybe we go in the woods somewhere and you can walk us through prehistory of animals in human diets. Maybe you can make a few stone tools, do a few things. I said, oh, okay, I'm comfortable with that. So he comes out. I had a couple of my graduate students out there, and we had some deer and some rabbits and some ducks, and they're butchering them with stone tools. And I'm making some stone tools with the guy on camera, and we're talking through the prehistory of the human diet and when animals come in and how important they are. And then he says, hey, pick up one of those ducks for me and cut it open and pull everything out on the inside. And I'm like, on camera? He's like, yeah. Like, on camera. He says, yeah, it's Ireland. And I didn't really know what that meant, but okay. So I cut open this duck. I reached all the way up inside. I mean, all the way up to the neck. I pulled everything out, and I had it laying out on my arm, on my forearm. And I looked down at the anatomy of this duck, which is a granivorous bird. These ducks are designed to eat grains. That's what they do. And I realized the importance of how their anatomy allows them to do this and what we don't have. So when a granivorous bird eats a grain, it goes into their mouth and it goes into what we call a crop. And that crop is an enlarged pouch where the grains, it's a warm, moist environment where the grains will sit sometimes for 14 or 16 hours. And during that time, incredible transformations happen. Even though it's just sitting there, it's sitting in a warm, moist environment, which is exactly where a seed wants to be to support new life. Think about when you plant seeds into the ground, right? So it soaks, it ferments, and sometimes even sprouts. And that's the power that begins the detoxification of these seeds, and also the breakdown of these seeds and getting them ready for consumption. Then it goes down into what they call a gizzard. If anybody's taken apart a chicken or a turkey, you've seen these things, and they're two muscular discs, and these granivorous birds eat gravel on purpose. They eat rocks, and those rocks sit in between these discs, and literally they're stone grinding these grains that have already been through that chemical transformation in the crop. And then it goes into a digestive tract, which for all intents and purposes for this conversation operates very similar to ours. And I'm thinking, oh my God, other than baking, the actual fire, they're making sourdough bread in their anatomies, is exactly what they're doing. And then I'm thinking to myself, wow, we don't have any of those things at all. And we're just trying to eat these grains that have been ground, but have been through none of the rest of the process. And I was wondering to myself as I'm looking at this duck, and this is all in like 30 seconds, but I'm thinking all these things. If I was able to take a grain and bypass those two things, the crop and the gizzard, and stick that into their digestive tract, which the part that operates like ours, I wonder what would happen. But then I'm like, I'll never know. I'll never know what would happen. And then I found out the answer to it a couple of years ago when I heard about a disease called angel wing disease. And angel wing disease is what happens to ducks and geese that are in city parks, and the old people, a few old people are sitting there feeding them Wonder Bread. They're eating this bread, and they get all sorts of malformations because of nutrient deficiencies. And here's just the power of the technology. They're eating, essentially, when they're eating the Wonder Bread, they're eating what they're designed to eat, right? They're eating grains, but they're eating grains that have been put through our modern system that screws them all up, and that ability to soak and sprout and ferment is no longer there once it's cooked. So they're not, even though they're eating grains, they're not allowing their bodies to do what it needs to do, and they actually get all sorts of malformations, and they look all crippled, and they have all sorts of issues. And that's exactly what we're doing to ourselves as humans when we're eating those grains in a modern industrial food system sense. Now, I will, and I know I probably advocate a little more for a more varied diet than you do, but again, I would never suggest somebody start eating bread that isn't. But if you approach those grains using ancestral methods to make them as safe and nourishing as possible, you're eating a completely different food than Wonder Bread. You're eating a completely different food than you can buy at a regular grocery store. And so sourdough bread is, one example with grains, soaking, sprouting, for longer periods of time. Great to do with also with nuts and legumes. Legumes are incredibly dangerous. I mean, I think it's 3 or 4 raw red kidney beans will land you in the hospital. Period. I mean, think about it. We don't think about how toxic our food is because we think once it's gotten to the grocery store, it's completely safe to eat. 3 or 4 red kidney beans will put you in the hospital. And if you eat more than that, you absolutely can die. The only way to make red kidney beans, or kidney beans in general, safe for human consumption is a combination of both soaking and cooking, long-term cooking. And you need both of those together. And if you skip one, you're in trouble. And a good example of skipping it is nowadays we have, the Instapots and all these pressure cookers. You can put dry beans into a pressure cooker without soaking them and come out the other end with something that is soft enough to eat, but it is not safe enough to eat. You have to go through that, both of those processes. And that's where I get excited about understanding ancestral approaches to these foods. And with your question earlier, Paul, with, how did our ancestors approach plants? Well, super cautiously and with a whole host of technology that allows them to do their best to mitigate the dangers of plants.
Yeah, I think it's so interesting. When I was with the Hadza in Tanzania, it's funny because I want to go back and spend more time with them. I know you've spent time with the Samburu people of Kenya as well, so maybe similar experiences. But the Hadza are really living like hunter-gatherers, probably the best example that I'm aware of on the planet. And, if you look at the literature on the Hadza, they'll say they eat all this fiber, and they'll say that they eat baobab seeds. But when I was there, they didn't even touch any of that stuff. They really didn't eat much fiber at all. They didn't eat baobab seeds. And you ask them, and it becomes very clear that they have this hierarchy of foods. And I don't think that our ancestors never ate plant foods or never ate seeds. But I think that it's very clear that when they get up in the morning, the first thing on their brain is animal meat, organs, blood, and fat. They want to hunt. And if they're out hunting and they see honey, they're going to eat the heck out of that honey. And if they're out hunting and they see fruit, they're going to eat some fruit if they want some fruit. So this is why I've sort of created this paradigm of an animal-based diet. It's like, okay, these are clearly, based on what I've seen and my clinical experience and even medical literature, the most prized foods by humans. If you're going to eat plant foods, eat the least toxic plant foods, which would be fruit and honey, if you consider that to be a plant food. And include organs and meat and blood and fat in your diet, because those are the things our ancestors thought of first. If you want to eat other plant foods, and I want people to have the most varied diet, I love your approach, which is understand that once you go out of the realm of fruit, you are going into dangerous waters, and you have to use the proper technology to detoxify these things. If you're going to eat grains, you must sprout and pressure cook and do a whole lot of work to these grains. And beans, you can pressure cook the heck out of them and sprout them and reduce the toxins somewhat. My concerns are that some of the toxins still remain. You really can't get rid of all the toxins with these methods, but you can clearly detoxify them. And I think our ancestors did and that's really the beauty and the brilliance of humans, because you don't always have a big kill unless you live in 2021. We can always get meat usually, right? But our ancestors needed these foods as like bridging fallback foods, so they had to know how to detoxify them. So I think that it's so interesting to think about these methods and the way that the methods really place the foods into a hierarchy. And I just want to emphasize that from my perspective, eating foods detoxified is better, but still there could be some residual toxins that could trigger people. I still think people, for instance, if someone has celiac disease, they still usually can't eat sourdough bread. There's still going to be gluten. Right. There's still going to be lectins. There's still going to be things in the wheat that could cause people immunologic problems. Certainly less toxic than a wheat that hasn't had this done to it. And you gave this great example of a bean, a red kidney bean with phytohemagglutinin and lectins. Yeah, it'll absolutely land you in the hospital unless you cook the heck out of it. And, somewhat hilariously, when I had Stephen Gundry on the podcast and we had a friendly debate, he noted that Joel Furman, who I've also debated on the podcast, pressure cooks his red kidney beans. And he was always pointing out, like, hey, Joel, if these red kidney beans are so good for you, why are you pressure cooking them? Even Joel Furman, this dyed-in-the-wool vegan, who I've debated in the past, guys, if you want to hear that podcast, it's in the history of this podcast, it's clearly acknowledging, hey, I better pressure cook because there are toxins in these foods. Talk to me a little bit about almonds. This is a really interesting thing because here's something that I noticed, Bill. When I was a raw vegan, I ate so many sprouted almonds, and they always made my stomach hurt. So even for me personally, and there could be some individuality, with sprouting and soaking, the almonds still messed up my gut. And I've told the story many times, but I used to go to these fancy like vegan dinners where they would make this like vegan tiramisu, and it tasted great. And inevitably, 15 to 20 minutes later, I had to leave the party because I was bloated to the point of feeling pregnant and just really, really uncomfortable with all of these almonds, even sprouted. But the history of almonds is quite fascinating. Think of them as like, they're like the darling, right? There's almond milk and all these things, but almonds used to be toxic, didn't they?
Oh, not only did they used to be toxic, they still are toxic. And look, I'll complete disclosure. I have an issue. My body has an issue with oxalates anyhow. And I've had 3 medical mysteries in my life that no doctor could explain, and every one of them were solved when I took oxalates out of my diet. And it turns out that the last piece of my diet that had contained oxalates that I had hanging on, that I finally removed it from my diet to make a difference, were almonds. It turns out, and because I'm so interested for myself in oxalates, it's one of those toxins that I haven't found very good evidence to show ancient processing strategies that really do a good job of getting rid of them. Fermentation, it looks like, helps a little. And there's ways of cooking, like some people suggest cooking with dairy helps, bind the calcium and the oxalates together, so it's not depleting calcium from your body when it goes through. But regardless, these are some nasty, nasty things. And one of the issues I think we have, and I hope this isn't off topic, but it's completely related, is we are so distanced from our food, where it comes from and how to prepare it, that we can't use common sense to approach food any longer, and we start listening to other people. And unfortunately, most of the other people are part of the modern industrial food system, and they're doing things. They're telling you to eat a certain way to make money, not because they're trying to make you healthy. If you think about it, even something as simple as harvesting and cracking nuts can transform the way you think about how many nuts you should be eating in a given setting. If I hand you, I can buy almonds at the dollar store. I can buy a bag of almonds at the dollar store. And if you're using things like price and convenience to understand how much of something you should be eating, you'll eat that whole bag of almonds, which is probably 7 or 8 times the oxalate amount you should be eating for the entire day just in that one bag of almonds. But if I had you harvest those almonds and crack open those shells and sit there and eat those, then you're going to eat, a dozen, so something almonds. It's a completely different thing. It's the same thing. We've screwed up that understanding, that relationship with our food and harvesting and processing because of things like government subsidies on wheat and corn and soy. I mean, hunting an animal, butchering that animal, and cooking that animal may seem like a lot of work. But if you compare that to preparing a field, planting the field, tending the field, harvesting the field, drying the grains, grinding the grains, and then cooking the grains to make a loaf of bread, they're night and day. I mean, they're completely night and day. But we can go to the dollar store and buy a 99-cent bag of flour and a little package of yeast, and all of a sudden we've taken 99% of that out. We're making a loaf of bread. We say, hey, this is wholesome, right? So I do think that connection is incredibly important. So, yeah, almonds are incredibly dangerous, and again, oxalates are something that I spend a lot of time looking at. But even through that same lens, from an oxalate perspective, as many of you know, almonds, spinach, those sorts of things are bad. But just as another example of a food that most of us eat on a regular basis that is loaded with problems are potatoes. Potatoes are loaded with problems, including oxalates. There's ways of mitigating some of it, and I spent some time in South America, in Bolivia and Peru, looking at ways of detoxifying potatoes. But again, it's a food that we eat massive quantities of without thinking. Many of us think eating massive quantities of them are making us healthier, and they're causing all sorts of issues.
I wanted to show this, Bill, because I've talked about this study a couple of times, and I don't know if I've ever shown it on the podcast. The title for those listening is Hyperoxaluria, which is excess oxalates in the urine, and genitourinary disorders in children ingesting almond milk products. How crazy is this one? So it's an abstract. It's a case series. We describe 3 children presenting with hematuria, dysuria, or kidney stones, which is blood in the urine, pain with urination, or kidney stones, and hyperoxaluria, too much oxalates in the urine, believed to be related to the ingestion of excessive amounts of almond milk products. Their conclusion is all genitourinary and urinary metabolic disturbances resolved after discontinuation of almond milk ingestion. Therefore, pediatricians should be aware of this potential link. I don't think many pediatricians are aware of the dangers of almond milk and genitourinary disorders in kids. It's crazy.
Think about it, and I'm familiar with that study, and there's a couple of other ones as well that are showing for the first time ever children under the age of 10 are presenting with kidney stones, and in every case they were in a family where the parents were trying to support a vegan diet where they're replacing milk, and we can have a huge conversation about milk, but replacing milk with almond milk, and these kids are drinking the same amount of almond milk as they would have been drinking with milk at that age. And I mean, it's unbelievable. It is unbelievable.
And don't even get us started on oat milk and the problems with oat milk, because it's usually containing seed oils and sugars. I also wanted to show this paper, which I think is quite interesting. While we are on the topic of oxalates, the effects of cinnamon, turmeric, and cinnamon and turmeric on urinary oxalate excretion, plasma lipids, and plasma glucose in healthy subjects. I did a controversial thoughts video the other day about why turmeric is bullshit, but the percentage of oxalate that was water soluble differed markedly between cinnamon and turmeric, which appeared to be the primary cause of greater urinary oxalate excretion and absorption from turmeric. Turmeric is very high in oxalates, guys. Just one reason why turmeric is kind of bullshit, in my opinion. That's the subject of the other video. We can link to the previous video that I did on that in the show notes for this episode. But in summary, we have a root, and Bill just talked about potatoes, but remember that roots are storage organs, and roots don't want to get eaten any more than the rest of the plant does. And so a lot of these roots, just like the seeds, are very high in oxalates. Sweet potatoes have a moderate amount, and these oxalates can accumulate in humans. Some fruit has oxalates too. You should know that like raspberries and blackberries are moderately high in oxalates. Dates are actually pretty high in oxalates. And I believe kiwis have a moderate amount of oxalates. So if you're oxalate sensitive, be aware of that. And if you're not eating oxalates from things like spinach or almonds or rhubarb or beets, you're probably going to be fine eating a little bit of oxalates from fruit. The last paper I'll show with oxalates is this one, which is one of my favorites. The title is Green Smoothie Cleanse, quote unquote, causing acute oxalate nephropathy. This is a woman who had pre-existing kidney disease, I believe, or maybe she was post-Roux-en-Y gastric bypass, which caused increased absorption of the oxalates, and she may have had some fat malabsorption. So she had some predisposing factors, but in a few, either short-term or long-term dialysis, yeah, she had Roux-en-Y gastric bypass for obesity, which predisposed her. But there are a lot of people out there who may be believing that a green smoothie is a healthy thing after a Roux-en-Y gastric bypass. And even for those of us that have normal fat absorption and are not going to be absorbing quite as many oxalates as this woman, green smoothie cleanses can still be a massive oxalate load in our bodies. It's scary stuff, and it's interesting. Thanks for sharing your personal experience with them as well.
Let me just mention, too, or on the topic, I don't know if you know who Sally Norton is. If you come across her at all, she's fantastic. She's coming out with a new book right now. I believe it's on pre-order about oxalates. And
I should probably get her on the podcast to talk about that. Yeah,
she's fantastic. She does a lot of great work with oxalates. I would highly recommend it.
And so you also mentioned tannins and saponins. We don't have to go into all the plant toxins, but there are a lot of different plant toxins that occur throughout the plant, especially in the seeds and the roots and other things like that. So I want to bring it back full circle. In the book, you describe being in Mongolia and seeing one of the yak herders harvest a yak. Describe that, because I thought it was so interesting to hear how they did it.
Lee, let me paint that picture first by saying something about the first meal I had in Mongolia, and then I'll tell you. So we landed in Ulaanbaatar. Ulaanbaatar is the main city of Mongolia. Half the population of Mongolia lives in this one city, and we ate at one of the higher-end restaurants in Ulaanbaatar, and I was so excited for this meal. And we sit down, and the two most expensive things the two top things on the menu was, one, the horse organ platter, and the second one was just, it would translate it into like meat. I don't know what, it was just like meat. And they came out, the two platters, and same table, same restaurant, same chef. It was a marked difference between the two. So the horse organ platter came out like it was in a 4-star restaurant, a 5-star restaurant. Like it was beautifully plated. All the organs were done in a separate way that you could actually see them and make out exactly what they were. And they are dressed with herbs and all. And then this other dish was all gray. But the one was super colorful. The other one was all gray, and it was chunk-sized, fist-sized chunks of meat that was every one of them was a combination of fat and gristle and meat and bone. Nothing was, you couldn't even use a knife on it. You had to take it and like gnaw on it, right? And it was all gray, and it wasn't dressed. It wasn't treated special, but it was right there. So that was the first experience in Mongolia, and that was in the main city. So weeks later, we're out on the steppe, and we're in the northern area. We're within sight of the border. I mean, Siberia was right there. It's in northern Mongolia. And we're at this yak herder's ger, right, yurt, and his closest neighbor was 20 or 30 miles away. And they were about to kill and butcher a yak. And he got two of his neighbors to come and help him. It was 40 degrees below zero. And these two neighbors came from, remember, neighbors was relative. It was 20 or 30 miles away. And they came to help. And they brought this massive animal out. They led the animal out. And they took a big sledgehammer, dropped this animal to its knees, and one perfectly well-placed strike, turned over the yak on its back. And now the yak's back is very rounded, so they put two logs, parallel logs down to make it so it didn't roll. So picture this massive animal on its back, feet up in the air. The first thing they did was they cut the neck to bleed it, and they captured all the blood, which they used every bit of it. And then what I thought was most interesting, I've been a hunter my entire life, and I've field dressed tons of animals, and I've never seen anything like this happen before. So most of the time what you would do when you clean an animal, just like you would clean a fish, is you start at the bottom and you cut up to the rib cage, and then you pull all the organs out. And in many cases, most people today, most modern hunters would discard most of those organs. And remember that single cut says a lot, because it was about just getting organs out. But that's not what happened in Mongolia. In Mongolia, what they did was they cut around the rib cage, and what they removed was like a shield. It would almost look like more like an autopsy, right? They took this huge piece of the rib cage and belly meat out, and you had complete access to all of the organs. So they took that aside. They put a tarp underneath kind of the bottom legs of the animal, clean tarp, and they grabbed the esophagus, kind of like I did with that duck. They grabbed that esophagus all the way up and cut it, pulled all the organs out at one time onto this tarp incredibly carefully. And the way I describe it in the book, it's like these three men, who I'm sure knew each other well and have done this before, but were operating like surgeons. Like they were in concert with one another. Every cut was incredibly deliberate. It was actually beautiful to watch. They pulled it all out onto the tarp. The only thing they didn't eat really was the gallbladder, and believe it or not, in this case, the spleen. Most native groups that I've seen do eat the spleen. This group didn't. They took the spleen and the gallbladder, fed it to the dog. The wife comes over, takes all the intestines with an ear-to-ear grin, so happy. There's a particular place in their yard where, remember, it's 40 degrees below zero. There's this frozen mound of intestinal contents that's growing. She cleans all the intestines out over there, and they make this. They use it. They eat the intestines, but also they stuff them with meat, and make a sausage-like thing. So she cleaned all those out. They took all the organs out. They cleaned the stomach out because they make a fermented yak butter and they cure it in the stomach. All these organs were perfectly manicured and cared for. And then as soon as that was done, they literally dropped their knives, and these three men picked up saws and axes, and they took the rest of that animal apart with axes. It looked like a horror movie. And what they were creating was similar to what I had in that first restaurant, those chunks every chunk had some meat and fat and gristle and bone on it. And the way they approached that animal, the way that the chefs in that restaurant approached that animal, and these butchers out on the Mongolian steppe, was exactly the way that I view our approach to animals through time in the past. We go, we get meat, we're happy about the meat, and that's fantastic. But what we cherish, what we deal with on a regular basis, which we go out of our way to access as much as possible and celebrate, are the blood, the fat, and the organs.
And I couldn't agree more. We saw the same thing when we were in Tanzania with the Hadza. One day, they hadn't had a successful hunt, and the guides bought them a goat. And when they were butchering the goat, it was different than anything I'd ever seen. They killed the goat by suffocating it, and then they cut its neck, and they drained all the blood, which they saved every bit of the blood that they could. And they made a stew out of the blood and all the organs. And I've talked about this in the past. When that liver came out of that goat, one guy had it in two hands, and he placed it very gingerly on a rock. It was clearly very highly treasured. really the most highly treasured organ, and all the other organs went into a pot with the blood, and they made this like blood and organ stew, which was actually pretty good. When they gave it to me, I was surprised because blood is kind of salty. I think that blood, they didn't even have to use salt in it, and it kind of tasted like I had salted it in my kitchen. So they boiled it all with the blood. I love that all these cultures save the blood. It's like one of the things that gets neglected so often. Is this, you think of blood as an organ, and it's always getting drunk, whether it's with the Maasai drinking blood and milk, or the Samburu drinking blood and milk, or the Hadza drinking just straight blood and the organs. I thought that was so cool that the Mongols, these Mongolian sheep herders, or these herders, these yak herders, were doing the same thing. And you see this pattern over and over and over, that the organs are treasured, and then they will eat the meat, but they really are excited about the organs, and they do then break the bones open to eat the bone marrow. And when I went hunting with the Hadza, we killed a baboon, and the next day we ate the brain, which all my friends were concerned I was going to get prion disease, which I seem to have escaped it at this point.
Congratulations.
There are not any prion diseases that I'm aware of that have ever jumped or have ever moved from baboons to humans, or any primates for that matter. I did a lot of research about it because when I told my friends, they were like, "Oh, you're going to get sick." Anyway, so that is a pattern that we see over and over, that organs, blood, and fat are the most highly treasured parts of the animal. Do you want to talk a little bit about what you saw when you were with the Samburu? I haven't heard about them in Kenya.
Yeah, absolutely. And we went there specifically because we wanted to do work and document, but also experience the drinking of the blood, just like the Maasai do. The Samburu and the Maasai are very closely related. So this is what happened there. So the Samburu are, like the Maasai, are nomadic pastoralists, which means they tend to animals, but they don't raise these animals for meat, although they will eat them. They raise the animals for milk and blood, and they look at the blood just like we look at milk, as a renewable resource, right? In everything that we talked about up until now, right, are people that have killed an animal and harvested the blood. But the Samburu and the Maasai will harvest the blood from a live animal just enough that they need. It's kind of like us giving blood at a blood bank, and then they regenerate the blood inside their bodies, and then they do it again and again. So this is how it went down there, and we spent days getting to them. It was several flights and days camping and driving, and eventually the last bit of it was through a dried riverbed, a wadi. We came to their village, and we went in. They took one of their cows and brought him over. The cow was fine, didn't resist at all. They put a rope around its neck. Same way like when they put a rubber band or a band around our arms giving blood, and their jugulars got huge. You could see it. And they walked up. I still have the arrow with this little, looked like a little toy bow and arrow. And the arrow tip was a piece of metal that was made so that it would only go in about a 1/4 inch. It had a bunch of twine wrapped around it, so it stopped after it went in for about a 1/4 inch. So they walked up to the cow. They shot this little tiny arrow. It went in and bounced out. And then all of a sudden, there's a stream of blood coming out of the cow's neck. And they collected it in a gourd. They collected about 1 liter. And as soon as they had what they needed, they took the rope off the neck, threw a little bit of dirt into the wound, and the cow, ambled off. And another week or two, they'll go back to the same cow. And they took this gourd and they set it on the ground and took a stick and they stirred it. And what they did was they allowed it to coagulate, and the stuff that coagulated around the stick they fed to the dog. They went to another cow, milked it, raw milk, equal parts, back and forth, the blood and raw milk. It was all mixed together, and we drank it. And it tasted like an irony, salty chocolate milkshake. And it was, and I know it may sound like I'm overstating this or I'm trying to prove a point on purpose, but I'm telling you exactly how it felt. I could feel myself being nourished. I mean, you knew you were getting something good when you were drinking this. You felt satiated and full. It was amazing. My whole family except my youngest daughter had it. She was very young at the time, and she actually thought, you can imagine a young child out of context seeing somebody shoot a bow and arrow and blood squirting out of its neck. She thought they were killing the cow, which obviously they weren't. And then, we drank this. What's fascinating is that group, during the dry season, the food for the animals, the forage for the animals is so poor. It's so dry and so woody that the animals have to eat massive quantities of food. And in order to do that, they need to just roam. So during the dry season, for months on end, the men and the boys leave and just let the animals go and follow them. And they follow them wherever they go. And they're gone again, for sometimes almost half a year. When they leave, they carry that little bow and arrow, a gourd, and a spear. And that's it. They don't even carry something to hold water. They eat twice a day, only blood and milk. Twice a day. And back at home at the village, the women eat that as well. They get extra blood and milk when they're sick or they're pregnant or they're lactating. But the sole basis of their diet is fresh blood and raw milk. And I remember when I first saw the three sort of young warriors that met us when we got to the village, and then coming into the village and seeing, they were the healthiest people. They were outwardly looking to me. I didn't test them, but looking at them, to me, they were the epitome of the human form. They were tall, they were lean, they were muscular. They had broad white smiles full of teeth. Eyes were completely white. I mean, they emanated health. And I remember coming home back here to Maryland, on the Eastern Shore of Maryland, and just thinking about that, and all these conversations about, what's a healthy human diet, and what are we going to do to the food system to improve the food system and feed this growing plant, all these arguments we talk about every day. And the two foods that are the staple of the diet of the people that I think are the healthiest people I've ever seen, out of those two foods, one is illegal for me to get, and the other is practically impossible for me to get. We haven't even scratched the surface of what a healthy human diet is, because it's not even in most of our perception of what is possible. But it was amazing.
You want to talk a little bit about milk, because it's an interesting thing for me personally. I wish that I could drink milk, Bill. I've tried raw milk, I've tried goat's milk, I've tried A2 milk, and my eczema always flares. But I do think there are a lot of people who can consume milk, and I think for those who can, there are a lot of benefits to potentially having dairy in the diet. So let's wrap up the conversation with a little bit of discussion of milk and how this can be incorporated into a human diet.
All right, thank you, because I'm really glad we get to talk about milk. I'm somewhat passionate about dairy, believe it or not. So I'm glad to have the opportunity. Let's start with this. Let's start with talking about what happens when we are infants and we drink milk. And it's sort of like, and then from that point, we can talk about what we can do to dairy to make it as safe and nourishing as possible. It's sort of like that duck example with the grains, but instead of looking at another animal, let's look at ourselves when we're infants. Now, we are designed, actually, the only food I can honestly say that I think humans are designed to eat, and it's only for a short period of our life, is milk. I mean, we are mammals. That's how we're defined. We are everything works perfect when we drink milk from our mothers at that stage in our life. And so I think it's great to start the conversation by looking at that. When we, as human infants, are drinking from our mothers, we're getting milk designed for our consumption. We're getting raw milk that, when it leaves the breast, is already in the process of fermenting. Okay, so we're drinking it, it's fermenting, it comes into our mouths. As soon as it goes into our bodies, it gets hit with a bunch of different enzymes, including lipase, which helps break down the fat, lactase, which helps break down the sugar lactose, and depending on the mammal, chymosin, or a chymosin-like enzyme, which denatures the protein and coagulates the milk and makes it sort of semi-solid. And the reason that happens is because when you're an infant and all you're doing is drinking a liquid, you have nothing solid to slow it down in our digestive tract. If we're drinking a liquid and it doesn't slow down, it doesn't have enough time in our stomachs to fully break down properly, and doesn't have enough time in our small intestines for those nutrients, when they're in the right state, to be fully absorbed. So we would become malnourished if it stayed in a liquid form. So what we figured out through evolutionary processes, and this happens for other mammals as well, we drink the milk, it's already fermenting, it's completely raw, teeming with live microorganisms. It comes into our guts, it gets hit with these enzymes, goes into our stomach, becomes a semi-solid, slows it down, continues to ferment in the stomach, and it is in a state that it can mechanically break down as well. It goes into our digestive tract, and the nutrients get absorbed, and it passes through and does the rest of the things that the food needs to do. Now, if you're burping a baby on your shoulder and it spits up on your shoulder and it looks like cottage cheese and it smells like provolone, that's because that's exactly what it is. What we did as a baby is we made cheese in our stomachs. That chymosin enzyme or chymosin-like enzyme is what in the cheese making world we know as rennet. And real cheese is fermented. Real fermented dairy products like yogurt and kefir are fermented. So if we take and here's the opposite end of the spectrum. When mammals start to get weaned off of solid food, weaned onto solid food and off of milk, they slow down, cease, or suppress the expression of a lot of those, or production of a lot of those enzymes. So in the case of humans, in the case of mammals in general, we stop producing chymosin or chymosin-like enzymes, and especially with lactase, we don't need that enzyme any longer, so we don't produce that lactase and we can't handle the lactose. Now in humans, it's actually, we think, most of us look at humans and think of those of us who are lactose intolerant are odd. It's not the case. It is odd that some of us were a part of several different genetic mutations that allowed us to produce lactase and safely digest lactose as adults. Only 60% of adult humans are lactose intolerant. That means most of us on the planet are somewhat lactose intolerant. Other animals, same thing. When they stop drinking milk, they're no longer creating the lactase, and they have a hard time, obviously, the same way as well. So now here we are in modern human adult bodies. Many of us no longer produce the enzyme lactase. We certainly don't produce the chymosin. We're not, I would argue, like many people would, we are not biologically designed to consume dairy as adults. And then most of the time the conversation stops there. But that's not where the conversation should stop, because if I'm right in my hypothesis, which I'm convinced I am because that's what I'm telling you guys, that we're not designed biologically to eat almost every one of the foods that we eat, then there's a deeper level of a conversation we need to engage in. And that is asking the question, not necessarily what we should eat, but how we should be eating. Are there ways to overcome our biological limitations and process that dairy in a way to make it as safe and nourishing as possible? And I do believe that there is. And the way that we do that is by mimicking what we did as human infants. So if we take, and again, you have to start with the right ingredients, right? The right raw materials. High quality raw milk from well cared for animals. If we start with that and then at least put it through the fermentation process, we're right there replicating a lot of what we would have been doing as human infants. But if we take that extra step too and also include that chymosin, that rennet, and we make a high quality cheese, and real high quality cheeses, fermentation is a part of that process as well, then we're talking about a completely different food. First of all, I would never advocate anybody drinking ultra high temperature pasteurized dairy and drinking it and putting it on their cereal, which should be cereal anyhow, but doing anything with it, that's safe. Most of the people around the world I've ever seen don't do that. In fact, the Samburu and the Maasai are oddities that they're not fermenting their milk. They're actually drinking it raw, although they do have some fermented beverages as well, or fermented dairy. But in that, the example I gave, they weren't. But every other traditional or ancestral group that I've ever encountered that consumes dairy, they always ferment it first. Kefirs, yogurts, cheeses, those sorts of things. So if we start with milk, raw milk from a high quality, well-fed animal, we put it through a fermentation process, and if we also make it into a cheese, it's even better, and then consume it, you're consuming a completely different food than obviously Velveeta or American cheese, but it's not like drinking a milk from a container or anything like that. Now, let me just kind of close this piece out by giving you an example, a real-world example, by understanding that process and the cheese-making process that can actually make a huge difference. Several years ago, when I was on sabbatical and writing this book, my family and I were traveling around the world doing research, but in most places I ended up speaking at the end of it, and in these different locations. And I would always get the same, no matter where in the world I was, I would get the same questions. Now, should we humans be eating bread? Should we be drinking dairy as adults and all that? And then towards the end, a couple people would always say, hey, listen, I get what you're saying about the dairy, but I'm lactose intolerant. I usually do very well on aged cheeses or yogurts or kefirs or whatever, but I don't get it with pizza. Like sometimes I'm okay with pizza and sometimes it's a complete disaster. What gives? And I didn't have an answer. I didn't know until I came back home. when we came back home after that year on sabbatical, I live in a very rural area, but we traveled across the Chesapeake Bay Bridge. We ended up hitting Trader Joe's and Whole Foods, and I went over to the cheese section. I love, like I said, I'm a little passionate about dairy, probably to a fault, but I love making cheese and doing these things. So I went over to look at the cheese section at Trader Joe's, and I picked up the mozzarella, turned it over, read the label, and I immediately knew the answer to their problem, their question. So I looked there, then I went over to Whole Foods, I looked at their mozzarella cheese, and it's so funny. We talked about this earlier. What are the filters that we use to try to, we're so disconnected from our food, to try to help ourselves make informed decisions about how to eat? Well, quite often it's brand, it's price, it's the packaging, right? So if you go to somewhere like Whole Foods and, number one, like, they have a great brand, or they have a great brand image. It's expensive, right? And then you go to their cheese section and they got their cheesemongers there and they got all the cheese spread out real nice. And so if you go there already, you're checking a lot of those boxes. And then you pick up the mozzarella cheese, and oh my God, the mozzarella cheese in Whole Foods doesn't look like that block of polio from the grocery store at Acme. It's actually a ball, and it's sitting in whey. And oh my gosh, the label has the colors of the Italian flag on it. There you go. Well, almost all of the mozzarella cheese you'll buy, even at Whole Foods, especially the fresh mozzarella, should not be called cheese. It is not cheese. It is something completely different, and I'll tell you why. Remember what we said about the babies and the human? Well, when you make any of the pasta filata cheeses, like mozzarella or caciocavallo or provolone or any of those, the first thing you do is you get the milk fermenting. You add some rennet or the chymicin, right, and to coagulate it. You cut the curds and deal with the curds, and then you allow it to ferment so it goes through a chemical and physical changes. The milk starts at a pH of about 6.8, and as it ferments, and the lactobacillus bacteria, remember the word lactose even in there, the lactobacillus bacteria eat the sugars, they eat the lactose, and create lactic acid. And as it creates more lactic acid, the pH drops. It becomes more acidic. When it gets to a pH of 5.2, you can heat it up, stretch the curds, and make your mozzarella, make your provolone, or make your whatever you're making. But it required that fermentation process, which takes around 6 to 8 hours or so to get to that point where it produced that pH of 5.2. And remember, because it's producing that pH of 5.2, it's because a bunch of the lactose was eaten by the lactobacillus bacteria. That's great. If you have some issues with lactose and eat a cheese made like that, there's some very good chances that you'll be absolutely fine. The problem is there's two ways to reach that pH of 5.2. There's a traditional way, which I just described, or instead of allowing it to ferment, you throw in citric acid or acetic acid or lactic acid, and you can change that pH. Instead of allowing it to go through chemical and physical changes over 8 hours, you can change it in literally less than a second. So though if you turn over a ball of a mozzarella cheese and look at the back of it, and it says vinegar, acetic acid, lactic acid, citric acid, anything that's acidic on it, turn it around and put it back. It's like drinking a glass of milk. It has the same lactose. It may look like mozzarella cheese. It may smell like mozzarella cheese. It may even taste like mozzarella cheese. It is not mozzarella cheese. And unfortunately, most of your pizza cheeses are made like that, and most of the cheeses you buy at the grocery store are made like that. In fact, if you want to go to the grocery store and buy a mozzarella cheese that is actually made now I can't say anything about the origin of the milk, but that has actually gone through the right process to make it as safe and nourishing as possible, the cheap cheese sticks in the cheese aisle are actually not always, but almost always made properly, and the high dollar mozzarella balls at the deli are actually usually not.
Wow. Have you ever seen a tribe eat colostrum?
Not a tribe, but I saw and did it too. They still eat it in Iceland in restaurants. A guy I just met the other day, a chef in Iceland, he makes it, and we ate. They bake it. It's got the same fat and sugar percentages as creme brulee. You literally just have to bake it. You can literally put it right into a dish, put it in the oven, pull it out, and it's a custard. And cut it just like custard.
Wow. And that's in Iceland. They do that.
Yeah. Yep.
I would try that. Even though I can't usually tolerate dairy, I would try that. And it's so full of like immunoglobulins and immune factors. It's incredible.
Oh, it's incredible.
So, yeah, it's so good. Man, I really hope that you and I get to go do some Indiana Jones stuff at some point. Have you ever found any treasure? So that's the last question I have for you. Have you ever found, like, you're an archaeologist, man.
Yeah, let me.
What's the...
The coolest thing I never found any treasure. I mean, the stuff that I'm looking at is tens of thousands or hundreds of thousands of years old, so treasure is relative. But the coolest thing I ever found myself, I was excavating on an island in the Delaware River just between New Jersey and Pennsylvania, and it was a site that was about 2,000 years old. And I was doing my dissertation at the time on the use of migratory fish in the Delaware River. There's some very similar things that happen there that you see in the Northwest coast with salmon. So they were doing it with things like shad and sturgeon, striped bass, and that sort of thing. But anyhow, I'm in the midst of this, and I was actually replicating at the time for my dissertation as a part of it a wooden tidal fishing weir to help catch these fish. We did a bunch of experiments, but I was excavating on an archaeological site. It was a 2,000-year-old site, and I pulled out a slate gorget. So it was a piece of slate that would have 2 holes on it, so they would wear it like a necklace. And on one side, they had etched, and this is 2,000 years old, etched the picture of a sturgeon. And on the other side, they had etched the picture of a wooden tidal fishing weir. So that was super cool because I was in the middle of that. But the coolest site, now I didn't find it, but the coolest site I've ever been on, and I did some work on, and I'm going to go back, and we're working on some tours to bring people back to, was actually in Kenya at a place called Lewa. Lewa is the largest white rhino preserve in the world. The family that helps run it, there's a foundation that runs it now, but it's amazing. But they have the largest 2 million or largest Acheulean hand axe site in the world, and you go to it, and it's on the Savannah, and you stand in the middle of this site, and it's like parking lots full of hand axes. I mean, thousands and thousands and thousands of hand axes just laid out like a parking lot. It is as far as you can see. It is unbelievable. So that's the coolest site.
Why are there so many hand axes there? Why are there so many hand axes there?
They don't know. And what's really more interesting to me as an archaeologist is not why are there so many hand axes there, but where's all the pieces of rock that come off when you make the hand axes. Like, they weren't made there. When you make a stone tool and take off all the pieces, for one stone tool, you'll have 3,000 flakes, right? So just on the ground. So if you sat there and made all those hand axes, you would imagine just piles and piles of these stone flakes. There's none. So they were actually made somewhere else, and they were there. I don't know why. I really don't know why they're there. Nobody does, and it's an amazing site.
It's interesting, and I'd heard that before, that around that time in our history as humans, we started to carry our tools. We started to move them around. We started to understand the permanence of tools and the long-term value of tools. And that's interesting that they would be moving them to a different place. So
moving, they could have been trading. They could have been doing, many different things. And I really think we need to give our ancestors a lot more credit than we do. And if you came, we do stone tool classes here as well. If you came and made a stone tool with me and you realize how much planning, it's like playing chess. You have to plan steps and steps and steps ahead to execute the reduction strategy properly. I mean, it's high cognitive level thinking.
I hope we do get to make a tool someday. Maybe we'll even get to eat some horse organs together.
That would be awesome.
That would be cool. Where can people find more of your work? How can they support what you're doing?
Thank you. So as you mentioned earlier, my book is coming out next month. I'm super excited. It's called Eat Like a Human, Nourishing Foods and Ancestral Ways of Cooking to Revolutionize Your Health. And I dive deep into all the things we talked about today. It starts off with a lot of information about our ancestral dietary past. And then every section after that is divided into different sort of groups of food: plants, animals, grains, maize, those dairy. And I talk a lot about the prehistory and history of those foods in our diets, what we have to look out for, how we can mitigate certain things. And then every chapter ends with a whole host of tips and recipes to take. It's great to talk about these things, but it's another thing to take this information and make it useful in your own home so that you can do things to nourish yourself and your family as much as possible. So that's what that book is. I'm super excited about it. It's on all the major outlets. It's on pre-order now. And as far as finding more information out about me, my Instagram, Facebook, and Twitter is at Dr. Bill Schindler, so Dr. Bill Schindler. My website is eatlikeahuman.com. And I'm super proud. I love to talk about these things. I love to teach about these things. But my wife and I have found out that, what we've been able to do for our family in the actual execution of the food has been so powerful for us. And we just started a company here called the Modern Stone Age Kitchen. And we are actually producing food in line with all of the research that we've been doing as a family. So you can find out that information at modernstoneagekitchen.com.
And what is it? Is it a restaurant or is it a food distribution company?
It's both. It's a food production company and it's a small restaurant. We're expanding, but right now we're producing food. We're doing theme meals. Education is a huge piece of what we do as well. So we do a lot of classes and we do a lot of teaching through food, themed meals, those sorts of things.
And it's on the eastern shore of Maryland. So if people are
Yes.
listening to this and they live in sort of the Northeast, they can reach out, maybe come check it out.
Yep, come out anytime. I'd love to give you a tour, show you around, or come take a class or have some of our food.
Awesome. Amazing. Thanks for coming on, brother.
Hey, thanks for having me. I'm so glad we're finally able to connect. Love what you're doing, and I'd love to support you.